Hi students, good evening. So today is an kind of important day for the work energy and power chapter. I think you guys can guess it what is the reason, because this is the last session of the work energy and power chapter. Okay, so we are just left with the discussion about the explosion. With that we'll be able to wind up the work energy and power topic. So we'll begin with the idea of explosion, like the way we said, right? Just like collision, explosion is also an independent event. Now we can talk about explosion of a bomb or a radioactive nucleus that will disintegrate. So bomb will explode into different fragments. A radioactive nucleus, right? Because it will be unstable, it will disintegrate into 2 or 3 smaller fragments. Okay. So both these phenomena, right, we can consider them to be like what? The equivalent of an explosion. Since the explosion happens because of the internal forces. Because after the explosion, what we generally see is the particles will be gaining kinetic energy. Where they will get the kinetic energy from? They will get the kinetic energy from the internal energy of the particles. So if you look at bomb, right, what happens? There will be chemical reaction that will happen. The chemical energy that is released during that reaction will be the one that will result into kinetic energy of particles. Same way in case of the radioactive phenomena, the radioactive energy, we'll study about it when we go to the modern physics chapters. During a radioactive phenomena, right, some of the mass will be converted to energy. That is what we okay. So that is how we will be able to find what is the energy released during the radioactive phenomena. But the idea is the kinetic energy for the particles, right, is coming from the internal energy of the system, whether it is the chemical energy or the mass energy, like that. Since it is an independent event or the event happening because of the internal forces, right, the momentum of the system. So here system means what? Initially we will have that one object. Okay, finally what we are going to have in the final state, we will have the particles or the fragments that are coming out of the explosion. The initial momentum of that object, whichever is there, will be equal to the final momentum of all the particles that are released as a result of the explosion. But in most of the cases, you know what we'll have? In most of the cases, in the initial state, the object may be at rest. Like we'll say bomb, which is at rest, exploding, like that. Most of the cases, the initial state, the object may be at rest. But we can also have examples. We'll talk about it. Like, you know, we have a projectile, oblique projectile, or any projectile for that matter. When we release the projectile, right, somewhere in the space, the projectile might explode. So here the object which is exploding, right, that is also in motion already. Okay, so either we may have the initial object at rest, that is what we'll have in good number of questions. Sometimes we can also have questions where the object initially might itself be moving. Okay, but whichever it is the case, the initial momentum of that object that is there before the explosion is equal to what? The sum of momentum of all the particles that are released as a result of the explosion. Okay, that is the one equation that we will be able to have. And obviously here we cannot use conservation of energy. Conservation of energy means I'm talking about the conservation of kinetic energy of particles. That cannot be used. Why? Because we are ourselves saying, right, some amount of internal energy of the particles will be converted into the kinetic energy. So here the kind of question that might be asked is, what is the kinetic energy change, or how much kinetic energy is generated, like that they can ask questions. Means initially the object will have some kinetic energy, right? Finally, if you add up all the kinetic energy of particles, that is our final kinetic energy. What are we talking about here? The final kinetic energy of all the particles, when you add it, it will be more. That is the situation we are talking about here, right? So the kinetic energy generated means it will be what? The final minus initial. That is going to give us what is the kinetic energy generated. Generated means this is generated because of the explosion. Okay. So this is about the idea of explosion. Again, we will talk about this in modern physics also when we look at this radioactive decay, right? There we will talk about this same principle. The explosion idea, we'll again talk about it when we go to the modern physics nuclear chapter. Okay, but this is what we have to use in case of the explosion. We can use what? Conservation of momentum. That is the equation we can use, and we will not be able to use the conservation of kinetic energy. Instead, we can also have questions where they themselves will ask us to find what is the kinetic energy generated, or to find what is the increase in kinetic energy, like that. Okay, so let us see what kind of questions can be asked. Look at this. That's it. The principle is only one equation. Broadly speaking, we'll have only one equation. What is it? Conservation of momentum. That's it. So we'll see a lot of problems that we can frame in this explosion, right? All of them will be framed in such a way that they can be answered by using this one principle. A bomb of mass 9 kg explodes into two pieces. One is 3 kg, other is 6 kg. The velocity of the 3 kg is what? 16 meter per second. Okay. The kinetic energy of the 6 kg mass is how much? So as I said, right, unless they say that the bomb is moving like that, we have to assume that this is at rest. That's what I said right now. So unless they particularly give that the bomb is moving like that, we have to assume that that is at rest. Okay. So initially the 9 kg bomb is at rest. Means what is the initial momentum? In this case, what is the initial momentum? That is 0. That is what? 0. Okay. Now the explosion is giving two parts. One is the 3 kg mass, which is going with a speed of 16 meter per second. Let us say it is going to the right side. Then 6 kg also will get some velocity. 6 kg has to move in a direction which is exactly opposite to 3 kg. The 6 kg, right, has to move in a direction which is exactly equal, which is exactly opposite to the 3 kg direction of motion. Why? We will see it. Why? Because what is the initial momentum of the 9 kg? That is 0. When we talk about the final momentum, right, so final momentum means what? The 3 kg is having a speed of 16 meter per second towards the right side. Okay, so 3 kg into 16 meter per second, that is the momentum. The 6 kg, let us say its velocity is v. Its velocity is what? V. Okay, then the momentum of the 6 kg particle is what? 6 kg into v. Total final momentum means we have to add both of them, right? This should be equal to what? 0. That should be equal to what? 0, which means what? Look at this. 3 into 16 is what? That is 48. 48 kg meter per second is equal to, let us take this to the other side, minus 6 kg into v bar. Okay, so we can see there will be some cancellation. What is it that we are having? So 6 ones are 6 8s, correct. So what is the v bar coming as? 8 meter per second. You know what is the meaning of this minus? Because we are taking 16 meter per second as plus, so the right side is taken as what? Positive. Minus means what? This 6 kg will be moving exactly in opposite direction with how much speed? 8 meter per second. So not only in this case, in any explosion, right, if object is exploding into two parts, if an object is exploding into two parts, let us say it is producing, so here we got the speed of that 6 kg part. What is it? 8 meter per second. From that we can find the kinetic energy. What is the kinetic energy means? The kinetic energy of the They are all particularly asking what is the 6 kg mass kinetic energy. What is the formula? Half into 6 kg into 8 square. Okay, 8 meter per second square. Okay, so what is it? We are having 3 into 64, that is what, 192. Everything is in the SI system, right? So it will be what, 192 joules. Look at this, what will be the answer? It will be what, 192 joules. Okay, now the thing I said, right, if a bomb or something is exploding in two parts, if it is exploding in two parts, both these parts, right, will have to move exactly in opposite direction. We'll see why. Let us say an object is exploding in two parts, m1, m2. The velocity of m1 is v1, the velocity of m2 is v2. Okay, if this object is initially at rest, means what, initial momentum is 0. If the object is initially at rest, means initial momentum is what, 0, is equal to final momentum means what, m1 v1. Final momentum means what, it is what, m1 v1 plus m2 v2, right? What is the final momentum means? m1 v1 plus m2 v2, correct? So check it, what is it that we'll have, m1 v1 plus m2 v2. Now just rearrange them. Minus m1 v1 is equal to m2 v2, which means we can see clearly here v1 and v2 will be exactly in opposite direction. Means if the second m2 is going towards the right, if m2 is going towards the right, then m1 has to move towards the left, so that the momentum, right, magnitude wise they must be same. If you look at the magnitudes, right, if you take the modulus, means magnitude wise the momentum must be equal, direction must be opposite. So when you add them, that will be adding up to 0, because momentum is a vector quantity. Because momentum is what? It is a vector quantity, right? That is the reason why if an explosion is happening and we are getting two parts, how the two parts will fly off? They will be flying off exactly in opposite directions, so that the momentum of these parts will be equal in terms of magnitude but exactly opposite in direction. So when you add them, means it will be adding up to 0. Okay, check it guys, whether you're able to get this answer or not. What should be answer? 192 joules must come. It's a straight question. Look at this one. This is the kind of question I was talking about, right, regarding this radioactive decay. So radioactive nucleus, mass number A, initially at rest, emits alpha particle with a speed v. What will be the recoil speed of the daughter nucleus? So this decay is also called as what? We call it as alpha decay. So what is the decay going to be called as? Alpha decay. You know what is alpha decay means? In this decay we are going to produce helium nucleus. That is what is the alpha particle. Alpha particle means what? Helium nucleus. Okay. So look at this. We have the radioactive nucleus of mass number A. Okay. Mass number A means its actual mass will be what? If say for example we are saying for iron, okay, the mass number is some 56, or no, for sodium for example we are saying the mass number is 23. The atomic mass will be what? It will be what? 23 atomic mass unit approximately. Atomic mass unit will be what? Atomic mass will be approximately 23 AMU. But mass number and mass are different. Mass number is what? It represents number of protons and number of neutrons. Mass will be actually mass. Okay, but if you look at the values, right, they will be almost same. Okay, because most of the mass of the atom, right, will be contributed by what? It will be contributed by the protons and neutrons. And if you look at the nucleus alone, right, definitely it will be having only what? protons and neutrons. But when we go to the radioactive chapter, right, there we'll see some differences will come. But here what we can assume, the mass of this will be, in terms of value, it will be equal to what? A, the original radioactive nucleus. It is undergoing the decay. One side it is throwing out alpha particle. Alpha particle mass number is 4. The daughter nucleus will have to go exactly in the opposite direction. Just now only we are saying, right, it has to go exactly in opposite direction. Daughter nucleus, what will be the mass number? It will be A minus 4. Because the alpha particle, what is the mass of that? 4 units. The daughter nucleus will have how much mass? A minus 4. The alpha particle is having a speed V. They are asking what is the recoil speed of the daughter nucleus. Let us say the recoil speed of the daughter nucleus is V dash. Previously only we concluded, right, that two parts that are coming will go in exactly opposite direction, but their momentum magnitude will be equal, which means what? 4 times V will be equal to A minus 4 times V dash in terms of just the magnitude. So what is the V dash value? 4V by A minus 4, that is our V dash. So that is the recoil speed of the daughter nucleus. Recoil speed means what? Like the way we use, right, recoil speed of the gun, like that. So after releasing that alpha particle, the remaining daughter nucleus, right, is going back or going in the opposite direction with this much speed. That is the reason why they use the word recoil speed. Check it, guys. What is the answer for this? Option C. It is just extension of what we discussed before, right? Whenever there is an explosion which is giving 2 parts, right, both the parts will have to exactly fly in opposite directions. Both of them will have to fly exactly in opposite directions. Okay, I guess this is clear. So here the thing is, in place of mass we have used the mass number, because as I said, right, for most of the nucleus the mass number and the mass of the nucleus we can equate it. Unit wise mass number will be having no unit, it's a number. Mass will be in terms of AM unit. Okay, let's go to the next question. Stationary particle, like this sometimes they can particularly mention. Stationary means what? This is already at rest. Stationary means this is already at rest. Stationary particle explodes into 2 particles, M1, M2, which move in opposite directions with velocities V1 and V2. Means, you know, stationary particle is there, it is exploding into M1, M2. They are moving in opposite direction. They are only saying all this. The ratio of their kinetic energies, means they ask us to find what is the E1 by E2 ratio. First of all, what is E1 means? Half M1 V1 square. What is E2 means? Half M2 V2 square. Half is cancelled. What is it? M1 V1 square by M2 V2 square. Okay, now what is the answers? Check it. Is there any option? M1 V1 square by M2 V2 square. Do we have an option like that? There is no such option. The options are in terms of what? Just the masses. And only option D is having both mass and velocity terms. So here we will have to look for any relation between the mass and velocity. Remember, when the stationary means what? Initially, stationary means what? Initially that object, right, is at rest. Correct? Means initial momentum is what? 0. So the final momentum of both the particles should add up to 0. Already they are moving in different directions, right? Means the magnitudes of the momentum, right, M1 V1 should be equal to what? M2 V2. The magnitudes of momentum, must be equal. The magnitudes of momentum must be what? Equal, right? M1 V1 should be equal to M2 V2. So look at this. Here we will just do some simplification now. E1 by E2 is equal to, we will do some simplification here. Look at this. E1 by E2 is equal to what? We have M1 V1 square by M2 V2 square, right? So let us just a little bit rearrange them. M1 V1 into V1 divided by M2 V2 into V2. Since M1 V1 is equal to M2 V2, cancel it off. What do we have? V1 by V2. But still That is not there in the answer. Now we have to look at m1 v1 is equal to m2 v2, right? So from here, what is v1 by v2? It is nothing but m2 by m1. So v1 by v2 can be written as what? In terms of mass, right? What will be the ratio? v1 by v2 will be equal to what? m2 by m1, right? So what is the answer for this? v1 by v2 will be equal to what? It will be equal to m2 by m1. So what is the answer? It is option A. So they are asking us what is the ratio of the kinetic energies. We are simply writing down what is the expression for the kinetic energy. From there onwards, we are simplifying. In this, what is the relation that we are able to use? The two particles that are coming after explosion, right? The magnitudes of momentum of particles must be equal. The magnitudes of momentum of particles must be what? Equal. Okay. So I hope this is clear, guys. We'll move on to the next one. An explosion blows the rock into three parts. So here also they are not mentioning, means we'll consider that the rock is at rest. It is blowing the rock into three parts. Two parts go off at right angles to each other. These two are what? 1 kg, which is moving with 12 meter per second, and 2 kg, which is moving with 8 meter per second. Okay. If the third part flies off with a velocity of 4 meter per second, what is its mass? That is the question. So look at this. Three parts are there. So let us say 1 kg is going to the right side. What is the speed they are giving for it? 12 meter per second. 2 kg is going at 8 meter per second. Let us take it to the right angles. Okay, you can see that they are both, after explosion, they both are moving at right angles. Now let us say this is having a momentum P1, this is having a momentum P2. Initially the rock is at rest, means what? The initial momentum of that rock or the object is 0. So finally, when we look at the momentum, if you add the momentum vectorially, because momentum is a vector, right? You have to add vectorially only. When you add momentum of all the three particles vectorially, they must add up to 0. They must be adding up to what? 0, correct. Now you see here, P1 is to the right and P2 we are taking it like up. The resultant of them will be along a direction which is in between the two, right? That is the resultant of 1, 2. What about the value? What will be the value? This is what? 12 kg meter per second. This is 8 to the 16. What is the resultant? They are at right angles, right? Means 12 square plus 16 square. What is 12 square plus 16 square means? 12 square is 144. Okay, so what is 12 square? 144. 16 square means 256. That is 400. Means the resultant momentum, right? The first particle and second particle, what is the resultant momentum? The resultant momentum 1, 2 will have a magnitude of how much? 20 kg meter per second. We are indicating even the direction for that. It will be along a line which is in between P1 and P2, right? That is the resultant. Now the third particle momentum should be exactly equal in terms of value, but opposite in direction to the resultant of 1 and 2. Then only they add up to 0, correct? The resultant of 1 and 2 is along a direction like that. The third particle momentum should be exactly in opposite direction and equal in terms of value, means the third particle momentum should be what? 20 kg meter per second. So P3 should be equal to what? 20 kg meter per second. But they are saying the velocity is what? 4, right? So if you say mass is m3 into 4 meter per second, that should be equal to what? 20 meter per second cancel. 4 ones are 4 5s. So what are we getting here? m3 value. m3 is what? 5 kg. The third particle, right, should have how much mass? 5 kg. How are we solving the question? We are looking at the condition, right? Initially that rock is at rest, means the initial momentum of the rock is what? 0. So finally when three parts are coming out of it, right, the momentum of all the three parts must add up to 0. that is the principle. So what is happening here? Particle 1, particle 2, we have the momentum, they are at right angles. If you take the resultant of them, means third particle momentum should be exactly opposite in direction but equal in terms of magnitude. Okay, based on that we are able to get what is the mass of the third particle, because for the third particle, right, they are giving us the velocity, they are asking us to find what is the mass. Okay, let us look at another question. A body of mass 4m is lying in the xy plane at rest, means that 4m is at rest. It suddenly explodes into 3 pieces. 2 pieces each having mass m move perpendicular to each other with equal speeds. Then the total kinetic energy generated due to the explosion. Almost similar thing but little bit different question. Initially we have that 4m which is at rest. Means initial momentum is what? Same concept, right? What is the initial momentum? 0. Here m is moving with the speed v, another m is moving with the speed v, like that. The third, what is the third mass going to be? 2m, right? Because total mass is 4m, means 2 parts are m and m, means third part will be what? 2m. So here look at it, 2 parts are going at right angles, means the resultant of them, right? Look at the resultant of them. What will be the resultant? Resultant momentum is what? This we call as P1 and P2. The third particle momentum, let us say P3. The resultant momentum is what? For P1 and P2, the resultant momentum is what? Root of m square v square plus m square v square. What is it? Root 2 mv. The third particle 2m momentum should be equal in terms of value but opposite direction, just like the way we discussed. Why? Because the P1 plus P2 plus 3 totally they will add up to 0, because the initial momentum of that body is what? 0, right? So P1 P2 resultant, that should be equal in terms of magnitude for P3, but direction wise must be opposite. So what about the magnitude balance? Look at this. If you say the velocity of the third particle is v3, like that, we have to find it. What is the momentum magnitude balance? Root 2 times mv is equal to what? Root 2 times mv is equal to, what is the relation we'll have? Root 2 times mv is equal to what? 2m times v3. m gets cancelled. So root 2 into v by 2, that is v3. So what is v3 value? V by root 2. The speed of the third particle is what? V by root 2. But look at the question, what they're asking, the total kinetic energy generated, that is what they're asking, right? Means what? Initially the 4m is at rest, means it does not have any kinetic energy. Finally each of the parts are having kinetic energy. Just what is the kinetic energy of the first part? Half into m into v square. What is the kinetic energy of the second particle? Half into m into v square. What is the kinetic energy of the third particle? Because its mass is 2m. What is the speed of that? So look at this. This is half mv square plus half mv square, means mv square. So half and 2 cancels. M v square by 2. Totally what is it? 3 by 2 mv square. This is the final kinetic energy of all the particles. Initially 0, right? Initially that 4m is at rest, means the kinetic energy is 0. What are they asking here? The total kinetic energy generated due to the explosion, means what? The final kinetic energy of the particles minus initial kinetic energy, right? That is the kinetic energy generated. Initially 0. So how much is generated? 3 by 2 mv square. Initial kinetic energy 0, means how much kinetic energy is generated? How much it is? It is what? 3 by 2 mv square. Okay. So this is about the general explosion type. But in this, right, there is a very particular example, especially for the JEE mains and JEE advanced level, right? These projectile explosions, they are a very good example for practice. What is this projectile explosion? Like, we have an horizontal projectile, oblique projectile, any projectile for that matter. If it is exploding in the air and giving rise to different particles, remember the explosion happens because of what? Because of the internal phenomena, right? So if the projectile is exploding in the air, the different parts, right, may move in different directions. Like you can see, they are moving in different directions, but the path of the center of mass will remain the same. So whatever is the path of center of mass, because center of mass will be only moving under the influence of gravity. Center of mass will be only moving under the influence of gravity. Remember, we talked about, with the center of mass idea, right? We'll talk about it when we go to the next chapter also. The the system of particles and rotational motion, right? In that we'll talk about the center of mass in detail. But here the thing is, the center of mass means the point where the whole mass of that bomb or that projectile is assumed to be located at. Okay, so we'll have in the center of mass and the system of particles, we will be seeing that if you have particles of masses m1, m2, m3 like that, with positions x1, x2, x3, the center of mass position, right, will be given by m1 x1 plus m2 x2 like that, divided by m1 plus m2 plus m3. So this is how we'll be able to find the location of center of mass. So the different parts of that projectile might fly off in different directions, but the center of mass will be traveling in the same path. The center of mass will be traveling in the same path. Center of mass means what? The location where we'll assume the entire mass of that projectile to be located. How do you find the center of mass location? If you know that the different parts are m1, m2, m3 like that, they are at the positions x1, x2, x3. Then the center of mass x coordinate is given by what? m1 x1 plus m2 x2 like that, divided by m1 plus m2 plus m3. Similarly, if you want to talk about y coordinate, right, it will be what? m1 y1 plus m2 y2 and so on, divided by mass of all the particles. Okay, so we'll discuss in detail about the center of mass when we go to the next chapter, that is the system of particles and the rotational motion. But here the thing is what? The center of mass would go and as it is land at the range point. Remember, in the projectile motion we talked about the range point. What is the range point? What is the range? U square sine 2 theta by g, right? That location is called as what? Range point. The center of mass will just go land as it is, but the other particles might fly off in different directions. Okay, but in this case also it is what? Explosion. So conservation of momentum will be satisfied. The conservation of momentum principle will be what? Satisfied. Okay, so we'll see what kind of questions can be asked in this. Look at this. A projectile is fired from a gun at an angle 45 with the horizontal and with a speed 20 meter per second relative to the ground. Means what? We are projecting it at an angle 45 with the horizontal. That is the angle of projection. What is the speed? U is given, right? U is equal to what? 20 meter per second. At the highest point, the projectile explodes into two fragments of equal masses. Projectile is exploding into what? Two fragments of equal masses. We can say m and m. Okay, one fragment whose initial speed is 0 falls off vertically. Means the two fragments coming, right, one of them is just falling off as it is. Means its speed is becoming 0. It is just falling off there. Okay, how far from the gun? The gun is here. This is the initial point. This is the gun. How far from the gun does the other fragment land? Assuming the entire surface is what? Level surface. How far from the gun the other fragment will be landing? So here there are different ways of solving this question. We will solve the question by using the center of mass concept. Okay, we'll discuss about center of mass in next chapter, but if you look at the idea of the center of mass, right, whatever is the original path, center of mass will go and land at the range point. Correct? Where the center of mass will land, it will be landing at the range point. Correct? So if you take the initial starting point as origin, what is the range value? U square means what? What is the range formula? U square sine 2 theta by g, right? So U square means what? 20 square sine 2 theta. 2 into 45 means sine 90, that is 1 by g. Let us take g as 10. Okay, so what is it? 400 by 10 means 40 meters. So center of mass location is what? 40 meters. The first particle, there are two parts. First part is just falling off there. You know what is this distance going to be? Because the projectile motion is symmetric, right? So this will be 20. This will be another 20, correct? So the first particle is falling at a location 20. So we are looking at from the horizon, right? The first particle position is what? 20 meter. Center of mass position is what? 40 meter. Okay, they are asking us how far from the gun does the other fragment land. So let us say it is landing at a point X. We don't know what is it. The other point, right, is landing at X. That is what we are supposed to find. Both the parts are equal masses. So remember the formula for the center of mass X coordinate. What is the formula for the center of mass X coordinate? M1 x1, which is what? M into 20 plus M2 x2, that is M into X, divided by M1 plus M2 means 2M. In this M will get cancelled. X center of mass already we have. What is it? 40. So 40 into 2 is equal to 20 plus X. 40 into is what? 80. 80 minus 20, which is equal to 60, that is X. So the other fragment, right, will fall off at what distance from the gun? It will fall off at a distance of what? 60 meters from the gun. So here the idea is what? Since the explosion, right, is only internal phenomena, the center of mass location. Okay, so in detail we'll discuss about the center of mass and significance of center of mass in the next chapter. But here just the idea of center of mass traveling in the same path, because it will be under the influence of the same gravitational force. It will go and land up at the same point. Center of mass means don't think that it is like a particle or something. It is a theoretical idea. Okay, the two fragments, right, their locations are related to center of mass location by which formula? X coordinate of, because we are only talking about the X coordinate, right? All of them are on that line only, horizontal line. So X coordinate of center of mass is equal to what? M1 x1 plus M2 x2 by M1 plus M2. Based on that we are able to find where the other fragment will land. So this idea is an important one, because we have got, I mean, I think even in one of the past years also they have asked question in this model. A projectile of mass 3m is projected from the ground with a velocity 20 root 2 angle 45. So look at this. What is the angle? Angle is same, 45, but u is changed. What is the u? 20 root 2. At the highest point it explodes into two pieces. One is 2m and the other is m. Both pieces fly off horizontally in opposite directions. Means at the highest point what is happening? Highest point what is happening? It is exploding. Two pieces are coming. Okay, they are flying off in opposite directions. Mass 2m falls at a distance of 100 meters from the point of projection. This is the point of projection, right? We'll take it as the origin. Okay, mass 2m is falling at a distance of 100 meters. Find the distance of the second mass from the point of projection where it strikes the ground. So again same, we have to find what is the distance of the second part. Okay, so here the thing is again same logic, right? The center of mass will follow the original path, and it will be landing up at the range point. This is what the range point, the center of mass. So what is that range? Range is equal to what? U square sine 2 theta by g, right? What is it? U square means 20 root 2 the square. Sine 2 theta means 1. So what is it? 20 root 2 square means 800. So this is where it is. The 2m mass is falling where? So this is our 80 meter point. 2m is going like this. It is falling at, what is the position? 100 meter. The mass 2m falls at a distance of 100 meter from the point of projection. Okay, so here the mass m, we don't know where it will be falling. Let us say the position is x. Same concept, right? What is it? Center of mass x coordinate is equal to what? Mass m into its final position x. Mass 2m into its final position is 100. Divided by m plus 2m means what? 3m. Okay, center of mass is what? 80, right? 80 into 3 is equal to what? X plus 200. This is 240 minus 200 is equal to x. Means from the origin or that point of projection where the second mass will be striking the ground, it will be striking the ground at a position x is equal to 40, means at a distance of 40 meters. Okay, so here just keep this idea. We'll again discuss about why the center of mass will continue in the same path when we talk about the system of particles in the next chapter, because center of mass will be moving only under the influence of the external forces. So during the explosion, right, only thing changing is because of the internal phenomena. External force is the gravitational force only, that is as it is remaining same. So center of mass will keep moving, and the final position of center of mass will be the range point, that will be as it is. Okay, this again we will discuss in the next chapter also, but this idea will be useful in solving these questions in an easy manner. Look at the next one. A projectile mass 3 kg projected with a velocity 50 meter per second at 37 with the horizontal. So 50 meter per second. What is the angle? 37. After 2 seconds, explosion takes place. The projectile breaks into two parts, mass 1 kg, mass 2 kg. First part comes to rest after explosion. Straight away, the 1 kg is coming to rest, means its velocity is what? 0. Find the velocity of the second part just after the explosion. Just once the explosion is happening, they are asking what is the velocity of the second part. How do we do it? We can use conservation of momentum. We can write, because look at this, the velocity. So here we can solve the problem in different ways. Let us look at the representation of the velocity as vector. How? We can take the right side to be what? I cap, upward is j cap, downward is minus j cap. So in this oblique projectile motion, right, acceleration will be minus 10 into j, because it will be g downwards. What is the initial velocity? Look at this, 50 meter per second, making an angle of 37 with the horizontal, means 50 cos 37, that will be I cap, 50 sin 37, that will be the vertical component. What is cos 37 means? 4 by 5. So 50 into 4 by 5 means 40. Sin 37 means 3 by 5. So this is the initial velocity. For the projectile 3 kg, what is the initial velocity? 40I plus 30J. Explosion is not happening initially. When the explosion is happening after 2 seconds. Means we have to, first step is what? For the 3 kg, what is the velocity at 2 seconds? What is the formula? V is equal to U plus 80, right? Means 40I plus 30J, that is U, plus A is what? Minus 10J into T. So what is it? 40I plus 30J minus 20J, that is 40I plus 10J. That is the velocity of that 3 kg particle just before the explosion. So we are able to get the velocity in terms of the vector notation. We are able to get the velocity in terms of what? Vector notation. Now our role is not with velocity, our role is with what? Momentum. So just before the explosion, right, what is the momentum of that 3 kg block? What is the momentum? It will be what? 3 kg into the velocity. What is the velocity? 40I plus 10J. That will be equal to, because it is explosion, right? Final momentum. Finally 1 kg. After explosion 1 kg is coming to rest. Final momentum will be what? Only for the 2 kg. Let us say V is the velocity of 2 kg. Let us say V is the velocity of 2 kg, right? So what is the final momentum means? 2 kg into V. So look at this. 2 1s are 2 20s, 2 5s. So what do we have? V is equal to 60I plus 15J. The 2 kg part, right? What will be the velocity of the 2 kg part, or that second part after the explosion? It will be what? 60I plus 15J. What are we doing here? We are just, there are two steps in this question. First step is what? The 3 kg is not exploding as it is. It is exploding after 2 seconds. Means we are first getting what is the velocity of the 3 kg particle after 2 seconds. That is the first step. That we are able to get by using the vector equation. V bar is equal to U bar plus A bar into T. That equation we have used. Then at that instant, the momentum of the 3 kg particle we have. That is the initial momentum before the explosion. After explosion, right, 1 kg is coming to rest. So it does not have any momentum. Only 2 kg will have momentum. So if we say that the velocity of 2 kg is V, its momentum will be what? 2 kg into V. Just we equated initial momentum of the 3 kg before explosion is equal to final momentum of the 2 kg after explosion. Why? Because the 1 kg is coming to rest. Okay. So what is the answer for this, guys? The velocity of the 2 kg particle after the explosion is what? 60I plus 15J. If you want to get the value, because this is the vector notation, they have not given us the IJ notation, right? So we might be really required to get what is the actual value. What will be the actual value? Root of 60 square plus 15 square. So what is it? Here we can take out 15 square common. So means it will be what? 15 into root 17. 15 into what? Root 17 will come. Check it how this comes. Here we can, you take 16. 60 square means what it is? What? 15 square into 4 square. 15 4 is 68. So it will be what? 15 square comes out. Remaining inside is what? 4 square plus 1, that is 17. Let us look at this one. A shell is fired with a speed 100 meter per second at an angle 30 with the vertical. See, sometimes, while we are very careful, we might just get wrong in reading the question statement. Here, just observe carefully. They are not saying 30 with horizontal. They are saying 30 with vertical. Means what? 30 with vertical means what is the angle with the horizontal? 60. So if we make a wrong thing there, means the entire question will be going wrong. Okay. So it is making an angle 30 with the vertical means what is the angle with the horizontal? 60. At the highest point, so this is our regular case, highest point, it is exploding into two fragments in the ratio 1:2. Means if one of them is having a mass m, means other is 2m. Lighter fragment moves vertically up. Lighter fragment means what? M. It is moving vertically up with an initial speed of 200 meter per second. The speed of the heavier fragment immediately after the explosion is. So immediately after the explosion, they are asking us what is the speed of the heavier fragment. So here at the highest point, we look at before the explosion. Before the explosion, right? So what will be the total mass of the piece? 3m. Highest point means, remember what is the velocity? It will be only u cos theta, right? Because at the highest point, only the horizontal component of velocity will remain. Means the velocity will be what? 100 into cos 60, that is what? Half. Okay. So the Again same, here we'll take the right side to be I, up is J, down is minus J, like that. Okay, so at the highest point for the 3m, right, what is the momentum before the explosion? What is the momentum? 3m is its mass, speed is what? 50 I, that is the momentum. After the explosion, right, what they are saying, the lighter one, which is mass m, is going up with 200 meters per second, means the momentum of the lighter one is what? M into 200 J. They're asking us what is the speed of the other fragment. Okay, so first we will say the velocity is v, other fragment velocity is what? V. So what will be its momentum? 2m into v. Its momentum will be what? 2m into v. This v we have to find. Again same concept, right? What is the concept? The momentum of that 3m before the explosion is equal to what? Total momentum of both the particles after explosion. So look at this, what we will get? Momentum of the particle 3m before explosion means what? 3m into, that is what? 50 I, is equal to momentum of particles after explosion, m into 200 into J plus 2m into v. This v is what we are looking to find. So observe this carefully. M we can cancel on either side. 3 into 50 is what? That is 150. Okay, 3 into 50 is what? 150. Okay, so look at this, 150 I minus 200 J, that is equal to v. Means if you divide both sides by 2 means what is the v value? That v is the velocity. What is that v? V is the velocity of that 2m mass, right? So look at this, what is the v? If you divide both sides by 2 means 2 gets cancelled. So what is it? 75 I minus 100 J. In terms of vector notation is coming, because our notation is what? Right side is I, upward we took it as J, downward is minus J, like that. But they are asking us the speed, right? Means we just have to tell the magnitude. Here we are getting the value in terms of vector notation. Here we are getting the value in terms of the vector notation, right? We have to tell the answer in terms of the magnitude. So check it guys, what will be the answer for this? What is the magnitude of this? They are asking us the speed means what? What is the magnitude? Root of 75 square plus, in this what is it? 75 square plus 100 square. So here it can be what? 25 into 3. This can be 25 into 4. So 25 comes out 3 square plus 4 square. What is 3 square plus 4 square means? 9 plus 16, 25. Root means what? 5. So 25 into 5. How much it is? 125. Everything is in the SI system, right? Everything is in the SI system. So it will be what? 125 meter per second. So the speed of that, what is it? Speed of the 2m just after the explosion is what? 125 meter per second. Again, what is the, see, you can see all these questions, right? We are using only one principle. What is it? Conservation of momentum. In all explosion, right? While we are trying to find the location where the fragments fall, there only we use that idea of center of mass location. Other than that, all the problems, that even the previous set of problems we solved, all of them we are using what? Conservation of momentum principle. So wherever we have explosion questions, right, we will be able to use the conservation of momentum principle like this. Okay, so with this we have covered the explosion part. Just go and practice some questions, not just an explosion but the entire work, energy and power. And in tomorrow's session, right, we will begin with the system of particles, center of mass and then rotation motion. So here we have just got some discussion about the center of mass, right? We'll study in detail about the center of mass and the other things related to the center of mass in the beginning of the next chapter itself. Okay, so in the next class we'll start with the, that's another very important chapter, that is the system of particles, center of mass, and rotational motion. Okay, so that is kind of considered as the highest weightage chapter in the entire mechanics. Okay, so we'll see in the next class.